What's up, guys? So we're moving on further into Unit 4. We're doing lesson 4.7, which is more congruent triangles. And we're going to be doing angle, side, angle, 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 side, and hypotenuse leg. So this is just going to be some more ways that you can prove triangles are congruent to each other. Let's jump into it. All right. So in the previous lesson, we learned about two different ones. We learned about side, 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 and side, angle, side. So now we're going to learn about three different ones that are going to help us to prove more triangle congruency. So let's go and look at the first one here. So the first one I'm going to look at is angle, side, angle, which is ASA. So just like the side, angle, side, the order does matter. It matters so much. So we have to make sure that the angle, the side in between it, and the angle on the other side of it is going to be congruent. So with that being said, here's going to be your definition. So if two angles and the included side, so remember, included means in between. So that means if I have a triangle, I have an angle and an angle, the side in between those two angles, that is what included means, okay? The side of the triangle are congruent to two angles and the included side of a triangle, then those two triangles are congruent to each other. So on my example over here, you can see I have one notch and two notch, one notch and two notch, and then the side that is in between the two angles is congruent to each other. So that means those two triangles are going to be congruent by side, angle, side, angle, side, angle, because that side is included in the middle. Okay, so those two triangles would then be congruent, which would make all the sides and all the angles congruent to each other. Okay. So the next one I'm looking at is angle, angle, side, so AAS. So again, the order does matter. So you have an angle, and then you have a side congruent. So then that's what's going to make those two triangles congruent. So by definitions, if you have two angles and a non-included, meaning not in between, side of a triangle are congruent to two angles and the corresponding non-included side of another angle, then the two triangles are congruent to each other, okay? So by example here, let's look at these two triangles over here. So on this first triangle, I have two notches, one notch, and a side. I have two notches, one notch, and a side. So right now, that corresponding side is congruent. So that means those two triangles are congruent by angle, angle, side, okay? And now lastly, we're looking at something called hypotenuse-leg. I'm going to go ahead and let you know the hypotenuse is only on right triangles. So that means this theorem right here, or this postulate, can only be used on right triangles. Can only be used on right triangles. This is what a right triangle looks like. It's got a right angle in it. Can only be used by right triangles. So by definition, if the hypotenuse and leg of one right triangle are congruent to the hypotenuse and the leg of another right triangle, then the two triangles are congruent to each other. So right now we can go ahead and see, I have a right triangle right now, so I can go ahead and look and test out hypotenuse leg. So the hypotenuse is the side opposite of my right angle, the side opposite of my right angle. Those two sides are congruent to each other. And then also the missing, or the third leg here. So that would be hypotenuse-leg theorem. So that means those two triangles would be congruent to each other, okay? So let's take this info, trade it over to our examples, and let's get going with it. So here we go. Okay. On example number 1, it says, given the triangles below, determine which triangles are congruent by angle, side, angle. So that means we're trying to find the two triangles that have matching angles and that included side is going to match with those, okay? So right now, let's go ahead and look. So right now, I have one notch, two notches with the side included. So now we're going to look for another triangle with the same combination. So right here, let's go and look. I do have this triangle that has an angle with one notch and an angle with two notches, but look, this triangle has that side in between the angles. This triangle has the congruent side not included with those two angles. So that means these two triangles would not be congruent by angle, side, angle because that side is not included. So let's go and look at the other one. So right here, I have one notch and two notches. So that means those two angles are congruent. And then the side in the middle of those two, meaning included, is congruent. So that means these two triangles are going to be congruent to each other. So let's go ahead and write my congruent statement. So right now I have QRS. So I have triangle QRS is going to be equal to, and then remember, I have to make sure this is written correctly. So right now Q, two notches is with a U. So triangle U, okay? R here has one notch, T has one notch, so those match up. T, and then obviously I need to write the other one, so UTV. So that means these two triangles are going to be congruent by angle, side, angle, because they have the matching angles and then the side included matches. So those two triangles will be congruent. All right, so now on example number 2, it says find the measure of angle A and angle L. So right now, let's go ahead and look at my information on my two triangles here. So right now, angle A has one notch, angle J has one notch, angle C has two notches, angle L has two notches, and look, the side that is included with those are going to be, they're going to be congruent, meaning in between those. So that means both of those triangles are going to be congruent because of the angle, side, angle postulate. So that means these two are congruent. So that means all the sides are going to be congruent and all the angles are also going to be congruent. So right now that means angle B and angle K would also be congruent, okay? So the side with 2 and 3 would be congruent, the side with 2 and 3 would be congruent, the side with 1 and 3 would be congruent, the side with 1 and 3 would be congruent. So that means all those sides would be congruent. So now it wants me to say, what is the measure of A? So A and J actually match up here. So that means if angle A and angle J, so if angle A is congruent to angle J, that means angle A is going to equal 62 degrees as well, because both of these triangles are congruent by angle, side, angle. Okay? Now let's look at the next one. So we need angle L. So angle L and angle C actually match up because both of those have two notches. So angle L is going to be congruent to angle C. So that means angle L is going to equal 51 degrees. Okay. And so again, both triangles congruent because of the angle, side, angle postulate. Okay, and so lastly on number 3, it says use the hypotenuse-leg theorem to find the value of x and y. So right now we are trying to find the value of x that is going to make both of these triangles congruent by the hypotenuse-leg theorem, okay? So I know, since this is a right triangle, they both have right angles, my hypotenuses have to be congruent. So I need to find the value of x that is going to make this equal the same value of the hypotenuse of this line, which is 13. So that means I need to set the hypotenuse, which is 4x plus 1. I need to set it equal to 13. So right now, I'm going to subtract 1 on both sides, which is going to give me 4x equals 12. And then I'm going to divide by 4 on both sides, which is going to give me x equals 3. So that means the x value is going to be 3 to make these two sides congruent to each other, okay? Because if I did 4 times 3, that would give me 12, plus 1 would give me 13, okay? So now in order for this to be congruent by hypotenuse leg, I need a leg to be congruent, or the same leg to be congruent. So I have two legs right here, but these are the two legs that actually end up are going to be equal to each other. So I need to set both of these equations equal to each other, okay? So that means I have to do, I'm going to move over here. I'm going to do it a different color. 2x plus y, and I'm going to set that equal to 8x minus 2y. But I already know in this situation what the value of x is going to be, so I'm going to go and plug that in and then solve for y on the basis here. So I'm going to have 2 times 13 plus y is equal to 8 times 13 minus 2y. So 2 times 13 gives me 26 plus y. 8 times 13, so 8 times 10 is 80. 8 times 3 gives me 24. 8 times 3 gives me 24. 80 and 24 give me 104. Okay, so now all I got to do is solve for the y here. So right now, I'm going to go ahead and add 2y on both sides. So that's going to give me 26 plus 3y equals 104. I'm going to subtract 26 on both sides. So that's going to leave me with 3y equals, if I subtract this, it should be 98, and then it should be 78. And then I'm going to divide by 3 on both sides. So 3 into 78, 3 will go into, so 2 times, give me a 6, bring down the 1, 3 will go into 18 6 times. So the final answer is going to be y equals 26. So ladies and gentlemen, if I want this to be congruent by hypotenuse leg, the y has to be 26 and the x has to be 3. And that would prove that both of those triangles are congruent by hypotenuse leg, because by hypotenuses have to be congruent and the leg has to be congruent as well. Okay, perfect. Good luck on your school check, guys.